Okay, we are gonna go ahead and go over section 9.2, which is using matrices to solve systems. So we first need to know how to turn the system into a matrix. So we'll first talk about how to create the matrix. Okay, so for example A, we'll use x plus 3y plus 2z equals 1. 2x plus y subtract z equals 2. And x plus y plus z equals 2. Okay, so we've seen a system like this before in section 9.1. But now we're going to take this and create it into a matrix. Now, how to create the matrix is you first have to make sure they're all in the proper order and they're all there. So we see x, y, z equals answer, x, y, z equals answer, x, y, z equals answer. So all of the parts are there and they're all in order. Then actually create the matrix, you just use the coefficients only. So the first row here will just be 1, 3, 2, 1. The second row will be 2, 1, negative 1, 2. And the last row will just be 1, 1, 1, 2. So we'll add in the matrix bars, and then just to show that this last column here where the answers, we'll just put a line there. So that's how to turn the system into a matrix. For example B, we'll look at x plus 3y equals 4, and x subtract 2 equals 0. So here we just have two equations, two unknowns. So to turn it into a matrix, you first look at, are all of the parts there and are they in order? So we have x, y equals answer, but here we have an x, there's no y, and the answer is in the wrong spot. So here we'll just have to rearrange and put in any unknown that's not in the correct spot. So this top one will stay the same, x plus 3y equals 4. But down here I'll keep x, since there is no y, I'll have to add in my own, plus 0y, there's no y, and then I'll add the 2 to the other side. Now after I have it set up like this, now I can set up my matrix. So the first row will be 1, 3, 4. The second row will be 1, 0, 2. Add in our matrix bars, add in the line there. Okay. For example C here, I'm actually just going to start just by showing you the answers. So say we knew x equals 1, y equals 2, and z equals 3. I just chose this to show you why this matrix method works. Alright, so here we have 3 unknowns. So I'm going to change this so that they're all in the proper position, and any variable that's not there, I'll put in myself. So for this x equals 1, I have an x, but there's no y, there's no z, and that's equal to 1. For here, y equals 2. There's no x, there's 1 y, there's no z, and that's equal to 2. Down here, there's no x, There's no y. There's one z, and that's equal to 3. Okay, so now we'll set up our matrix. The first row is 1, 0, 0, 1. The second row is 0, 1, 0, 2. The third row is 0, 0, 1, 3. So I did this example here to show you why this method that we're about to learn actually works out. The first thing I would like to point out is that this last column here were our answers. Our answers were x equals 1, y equals 2, z equals 3. And we have that here. X equals 1, y equals 2, z equals 3. Now, that only works out if the matrix right here is the special type called the diagonal matrix. So what this shows us is if our matrix has this special form where there are ones on the diagonal and zeros everywhere else, that this last column here will show us our answers, will show us what x, y, and z are. So, the idea behind the method today is that we will take whatever matrix we start out with, put it into this diagonal form, and after it's in this diagonal form, we know the last column will tell us what x, y, and z are. Now this method has a special name, and it is called the Gauss-Jordan method. So the idea is we will apply row transformations to reduce the matrix to diagonal form. Once it is in this form, we know the solutions will be the last column. So this is the Gauss-Jordan method. We're going to apply these row transformations, I'll talk about those in a second, to reduce the matrix we started out with to that special diagonal form. After it's in that form, we know those last column will be our answers. Alright, so first off, what are these row transformations that I am talking about here? You don't always have to use all of these. I'm just going to tell you the options of what the row transformations are. You could change the order of the rows. So if one row that's on the bottom, if it would help us to put that on the top to change it in that form quicker, then you can do that. The other thing that you can do is multiply or divide a row. The only one you can't do is 0. And the third row transformation is you can replace a row with the sum of that row and a multiple of another row. So I know that may seem confusing, but the idea here is we'll do that same stuff that we did before. We'll say, oh, we'll multiply row 2 by 3 and row 3 by 6 and then add them together. That's the same thing here. But actually, after we actually get that result, in our matrix, we'll actually replace the row with the result. Okay, so here are all of the row transformations that you could possibly use. So now let's talk about how do I actually change the form of this? What are the steps to take? And I think to see these steps, it's easier just to see the picture. So first off, to turn it to that diagonal form, your first step is to get the upper left element to be a 1. You know in the diagonal form, it has to be 1s on the diagonal and 0s everywhere else. So the first thing you would want to do is get the upper left corner to be a 1. Step 2 is after you have taken care of that, so we have a 1 in the upper left corner, you'll need to turn everything that's in that same column as that 1 into a 0. Step 3, so we're assuming we have a 1 in the upper left, everything else is a 0. Then you'll need to form that second 1. So it'll be that second one in the diagonal. Now after that, so we have a 1 here, these are 0s, we'll have a 1 there. You'll need to turn everything else that's in that same column into a 0. Then you just can continue on depending on how many rows and columns that you have. All right, let's actually see one. Our example is 2x plus 3y equals 7, and 3x minus 4y equals negative 32. All right, so first step, put it into that matrix form. So it'll just be 2, 3, 7, 3, negative 4, negative 32. All right, so step 1, we need to turn this into a 1. So our goal is that that upper left corner turns into a 1. So you think, how can that be done? Well, if I divide by 2, then that 2 will turn into a 1. So I will divide this entire row by 2. And remember, you have to do it to the entire row. Because the idea is these things are equal. So to keep that balance, you have to do it to the entire row. So our new top row will be 2 over 2, that's 1. 3 over 2, that's 3 halves. 7 over 2, that's 7 halves. And then this second row here will just stay the same. All right, step 2. Our goal will be to turn this into a 0. Our goal is to turn this 3 into a 0. But remember, I'm not allowed to multiply this whole row by 0 because then that just cancels everything out. So instead, we'll have to use that row transformation 3, where I'm going to add these two together to try to cancel it out. So I'm seeing here, if I multiply this 1 by -3 and then add it to +3, it'll cancel out. So my goal here is to, in place of row 2, so whatever my result is, I'll put it in for row 2. My plan is to do -3 times row 1, and I'm going to add that to row 2. Now, if you can do this in your head, that's great, but I like to actually write each step out. So the first one is I'll multiply row 1 by -3. So that is -3, -9 over 2, and -21 over 2. Then I'm going to keep row 2 the same. So 3, -4, -32. And I'm going to add these. So the -3 plus 3, that cancels out to 0. Then -9 halves minus 4, that is -17 over 2. Then -21 over 2, subtract 32, that is -85 over 2. Okay, so I'm going to keep row 1 the same. And row 2, I'm going to replace with my result here. Alright, so we're all done here. So I'll just erase this. Okay. Our next step will be to create our second 1. So we'll do that here. Remember, the 1s have to be on the diagonal. So, to create this into a 1, I can just multiply by 2 over -17. Alright, so I'll keep row 1 the same. And row 2, I'm going to multiply by this. So 0 just stays 0. This turns into a 1, which was the whole goal. So the only really calculation I have to do is these two. So we have -85 over 2 times -2 over 17. So that result is 5. Alright, we are almost complete. Our next goal is to turn this into a 0. So here again, we'll need to multiply and add. I'm seeing if I multiply this 1 by -3 halves and then add it, it'll cancel that out. So here I will take row 2 times -3 halves and add it to row 1. So I'll just do this off on the side. So row 2 times negative 3 halves. 0 just stays 0. 1 times negative 3 halves is negative 3 halves. 5 times negative 3 halves is negative 15 halves. Then we're going to add it to row 1 as is. So 1, 3 halves, 7 halves. Let's add that. We end up with 1. This cancels out to 0, which is good. That was the whole point. And negative 15 halves plus 7 halves, that ends up being, well, 8 halves, so 4. Alright, we're going to take this result here and plug it in for row 1. So I'll just put this up here. For row 1, we're putting in our result. For row 2, that's staying as it was. And now we have this matrix here in our diagonal form. And then this last column tells us our answer. So our x is negative 4 and our y is 5. So this example that I gave was just 2 equations, 2 unknowns. Your book has one for 3. The process is the same, it just takes a few more steps. Alright, so that is the end of section 9-2.